Welcome back to limit of sequence, and in this video we won't be using the definition unlike last two videos, which was quite tedious. In this video we would be proving the limit sequence, or we would be finding out the limit of the sequence using simple algebraic tricks. So the first one, just start with a nice and simple one. N plus c1, n plus c2. Tell me what the limit of this sequence tends to. Go and pause the video and find out. Limit n tends to infinity. This. So if we divide top and bottom, both the numerator and denominator, by n, we should be getting 1 plus c1 over n over 1 plus c2 over n. Let's try to make it a little clearer. 1 over 1 over c2 over n, and this should be 1, this should be 0, this should be 1, this should be 0 as n tends to infinity. So that should give us 1 over 1, and that should be 1. So this limit tends to 1. An interesting fact is when you have the same order of polynomial in the numerator and denominator, I will show you what I mean by that in this example. Say you have a third degree polynomial of n, 2n cubed plus 3n plus 6, and a third degree polynomial of n here, 5n cubed minus 3. Okay, it's 5n cubed. Okay, if that's the case, then its limit would be the ratio of the highest degree polynomial, the term of highest degree of n. So in this case, the coefficient of n cube is 2 and coefficient of n cube is 5, so this limit should tend to 2 over 5. In order to prove that, what you need to do is divide top and bottom by n cube, and you would find out. If you divide top and bottom by n cube, you would get 2 plus 3 over n square plus 6 over n cube, and in the bottom you would find 5 minus 3 over n cube. This would tend to 0, this would tend to 0, and this would tend to 0, and the thing that would be remaining is 2 over 5. If you have same degree polynomial in the numerator and denominator, so looking at that, you should be able to realize by just looking at the coefficient of the highest degree, you should be able to find out the limit. But what if both the numerator and denominator are polynomial n and they aren't of the same degree? Then if that's the case, if numerator is of higher degree, then the limit would tend to infinity. If numerator, for example, if this was 4th degree polynomial and this was 3rd degree polynomial, the limit would tend to infinity. And if denominator was of higher degree, then the limit would tend to 0. That's a cool trick to note out, and it can be useful in many cases. Having said that, and keeping that in mind, let's move on and do another example. Limit n tends to infinity, square root of n plus c1 minus square root of n plus c2, where cn and c1 and c2 are any real numbers. Okay, find its limit. Go ahead and pause the video. I thought you had a go, so I will show you how to do this. The quick answer to this is 0. Let's see. If we divide numerator and denominator by the conjugate of this, then things should be much easier. Square root of n plus c1, so square root of n plus c2, square root of n plus c1 plus square root of n plus c2. So what this should give us is this is squared minus this is squared, it's a minus b times a plus b. So if you know cool algebra trick from your primary school, maybe, okay, then you should be in no time realize that this should be, what should this be? This should be c1 minus c2, right? That should be c1 minus c2 over the square root of n plus c1 plus the square root of n plus c2. The denominator goes to infinity and numerator is some number c1 minus c2. So this tells us that this limit tends to 0. Okay, let's try to do some more cool examples. Limit n tends to infinity. N factorial over n to the power of n. Okay, what do you think this tends to? Go and pause the video and come back later. Well, the quick answer is 0. I'm gonna show you how in this video. First, note a fact that the answer should be positive number. I mean non-zero number. Answer can't be negative, because n factorial, that would also be positive, and n to the power n, that would also be positive. So the answer can't be negative number. And let's try to find the upper limit of this. N factorial, that would be 1 times 2 times 3 times all the way to n. And n to the power n would be n times n times n times all the way to n. So n over n would be 1. I mean, limit we are in this. This is 1 over n times 2 over n times 3 over n times n over n, right? N over n is 1. And each other limit tends to 0. This tends to 0, this tends to 0, this tends to 0. All the limit tends to 0, and this tends to 1. And this is 1. So what does this tell? This tells us that this limit over goes to 0. Let's look at another example. Five to the power of n cubed over n factorial. So what do you think the limit of this sequence tends to? Go on and pause the video. The quick answer is this tends to infinity. I will show you how. So 5 to the n cube, this can be written as 5 to the n square whole to the n over n factorial. And this can be written as 5 to the n square n times 5 to the n square over 1 times 5 to the n square over 2 all the way up to 5 to the n square over n. Tell me whether or not this number is greater than 1 or less than 1. The denominator and numerator, look at the numerator. Numerator is 5 to the n square and denominator is n. So this tends to infinity. This tends to infinity. All the every terms tends to infinity here. Since all the terms tends to infinity and we're timesing all of them, this limit as a whole tends to infinity. Let's try to do few more examples. I will do one more example in this video, and I will make part 2 of this video to do few other examples. Okay, limit n tends to infinity. Nth root of a. You guess what this tends to. Go on and pause the video and try to solve this. This limit goes to 1. And How do you prove this? Well, if we write nth to the nth of a as a to the power of 1 over n, and a to the power of 1 over n is same as e to the power of ln of a to the power 1 over n, right? And by using simple rules of logarithms, it should be e to the power 1 over n times ln a. Ln a, that's a constant, 1 over n, this tends to 0, so this power, everything here, tends to 0, and e to the power 0 is 1, so this limit tends to 1. The next question I'm gonna give you, and it could be quite hard to digest, but I'll try to explain it to you in best possible way I can. Limit n tends to infinity nth root of n, this tends to 1. I'm not gonna make you guess it. It tends to 1. Go and pause the video and try to prove this. So if you take the sequence like first root of 1, square root of 2, cube root of 3, fourth root of 4, and so on, this limit tends to 1. If you don't believe me, go on and pick your calculator and keep doing, and this number would be slowly approaching to us 1. That should suggest you that this tends to 1. But proving this, I will show you in this video. Like in the previous case, we'll be writing n to the power n, nth root of n as n to the power of 1 over n, and this should be e to the power 1 over n ln n. And if you use L'Hospital's rule, and you might be wondering what this fancy rule is, you may not have seen it yet. Then if you haven't seen this rule, then I will ask you to take this for granted. If you have seen this, then you can use L'Hospital rule to prove that this limit tends to 1. Just take the derivative of numerator and denominator and you will find out. So this tends to 0, this thing here, by using this rule. So this limit tends to e to the power 0, and e to the power 0 is 1. And let me do one more example here. Since I'm running out of space, I'll be able to do only one more. Nth root of n to the power of a, where a is some constant. And this also tends to 1. How? Well, I'll show you. This can be written as n to the power of a over n, and which is same as e to the power a over n ln n. And since limit ln n over n tends to 0, a times 0 would be 0, and this would tend to e to the 0, and that would be 1. Hope you enjoyed this video. Please like, comment and subscribe. I will meet you guys in the future video, and don't forget to check next part of this.